Hello, my name is Chris Duran and I am the project manager of Team Readmissions. On behalf of my team members David and John, I will be giving our topic presentation. So before I dive into our project's main objective, let me give a little background. So unplanned hospital readmission is when a discharged patient is readmitted into the hospital unexpectedly. And this is one of the leading topics of healthcare policy and practice, and is often used as a metric of performance or quality of hospital care. A large amount of the U.S. Medicare funds are allocated to this issue, and recently the readmission rates have been increasing with time. So that being said, the goal of our project is to develop and test a clinical decision support system, CDSS, for the following purposes. And the main one is to decrease the 30-day unplanned readmission rates, and also to decrease the average length of hospital stay. So we had the pleasure of meeting our stakeholders the other day via WebEx, and the first one is James C. Cox, and he is a director in the Experimental Economics Center at Georgia State University, and his associate director, sorry if I pronounce this wrong, but Vyolka Sadiraj, and she's also working in the same department at Georgia State University. And this middle guy is Dr. John F. Sweeney. He's a professor and chair in the Department of Surgery at Emory University School of Medicine. It's a business case. So the problem is right now they have a model which is good for 3 to 4 days. If a patient stays 3 to 4 days, but if the patient stays longer than 4 days, the model does not predict very well. And so our main task is to improve upon the current model. And how will this benefit the end users? The stakeholders and end users will have a better model that predicts the patient readmissions more accurately. And so for research requirements, as you can see, the first two tasks we've already completed, and those include extracting the data, so receiving the data from our stakeholders, which we will be training and testing. And we also were given default data values for unmarked entries in the data set because the data is not very clean. Also, we'll need access to supervised learning software algorithms, and this is to find the model which best predicts the data, best predicts the target value accurately, and we'll be considering multiple languages. How will FIRE be incorporated? So right now, the model we're working to improve is used by a prototype, and the future roadmap for this CDSS includes a smart on FIRE implementation, although we will not be addressing this implementation with our project, but will be creating much needed functionality to drive the decision support. Data resources which will be used a set of anonymized patient records, and the records, there will be attributes, and these attributes include maybe the patient's diet, any images, lab results, drugs, vital information, transfusions, etc. And later on we'll conduct the final tests on more test data, which is being held by our stakeholders currently, and this will be used to verify their overall model results. Technologies we'll use RStudio and RStudio, and we'll use whichever supervised learning method, whether it be SVMs, neurometrals, we deem most appropriate. Last but not least, here's our project schedule. As you see, here's my task, David's task, and John's tasks. Right now this is a very loose schedule, which will most likely be changed. As you can see, there's a lot of variance in here, as some of the tasks depend on the previous task, and so we'll have to address these later on. But right now, here's our schedule, in which we will try to stick to the best as we can. And that concludes my presentation.